record this class today. So just so you're aware. All right, so Unit 3, Lesson 3, covalent slash molecular compounds. In the first two lessons, we learned about ionic compounds. And we learned that one element.
Good morning. Please pardon this interruption. All students who need to take the CLT exam, please report to 249 at this time. Teachers have sent out a list this morning. Please have those students report to 249. They should be done by lunch. Thank you.
So just to remind you, with ionic compounds are made of cations that are ions that have given away electrons, and anions, which are ions that have gained one or more electrons. And we said in the second lesson of ionic compounds that typically this would be a metal and a non-metal, where the metal's given away and the non-metal gained. So typically, metal plus non-metal. Today when we get to polyatomic ions, I'll address an exception to that, but typically it's metal and a non-metal. Now, the difference between an ionic compound and a covalent compound is what happens with the electrons. In an ionic compound, there is a transfer of electrons, meaning that one element is giving away and another element is gaining. So there is a transfer of electrons in an ionic compound. But in a covalent compound, there is no such transfer of electrons. In a covalent compound, the valence electrons are actually shared between the two elements. And hopefully you have seen that in the tutorial. In covalent compounds, the valence electrons are shared instead of transferred. Now, this can only happen if the two elements have similar electronegativities to each other. And so covalent compounds are between non-metals only. There are no metals in covalent compounds, meaning sodium, lithium, iron, copper, potassium. All 80% of the periodic table is not in covalent compounds. Covalent compounds is only with non-metals bond, which is a very, very small component of the periodic table. However, that's most of the elements of life, actually. So even though only a few elements can form covalent compounds, billions and billions of different covalent compounds can be made because of all the different ways, for example, carbon can combine. And so you're going to just want to have this written down as we go into today's lesson, because knowing the difference between how to identify an ionic compound and a covalent compound is extremely important. And it's going to be important throughout the rest of this class. And believe me, it's actually going to be important no matter what AICE science you choose. Mr. Dime was just complaining on Friday that students didn't know by looking at a compound whether it was covalent or ionic. You know, it's a really, really important thing that you've got to get down in this class. It's going to be expected in any college level science class that you know the difference. So ionic compounds, I'm looking for metal and non-metal. Covalent compounds, I'm looking for non-metal only, which means from last unit, you still have to remember where your metals are at, and you still have to remember where your non-metals are at on the periodic table. All right, so let's go ahead and get started. I kind of already said this, so I'm going to skip it. I said that in the beginning. Yeah.
You go back.
For the slide here. So I already said this, but it's important to also note there's some more things you need to know in differences between ionic and covalent In ionic solids, because all of your particles are charged, positives and negatives attract, the forces between these ions are strong. Whereas in molecules, instead of molecular solids, you should write in molecules. The particles are not charged. So the forces between them are much weaker. So what this means is that ionic compounds tend to exist as solids, whereas covalent compounds can exist as solids, liquids, or gases, depending on various factors. So for example, CO2 is carbon dioxide. What state of matter is that in? Just context. CO2, carbon dioxide. Anybody ever heard of that? It's gas, right? And it's a covalent compound. H2O, water, made of hydrogen and oxygen, two nonmetals. What state of matter is that in? Liquid. Sugar, glucose, solid. So all this is to say here is that ionic compounds have strong forces that hold them together, so they exist as solids at room temperature. Always. All ionic compounds exist as solids at room temperature. They all are salts. They all look like salt. They might have different colors, but they're all salts. Whereas covalent compounds could exist in, depending on the compound, it gets more complicated. But covalent compounds have a wider variation. Properties. These are the two major classes of different chemical compounds that you've got to know the difference of: ionic compounds and covalent compounds. And like I said, you've got to know the difference of them just by looking at where the elements on the periodic table are that form the compounds. So while I'm waiting, let me pass out. I know I had asked you to write this in your notes, but I also wanted to give you a printout just so you know exactly what's expected of you in terms of what you are going to need to do. Okay. So hopefully I've given you plenty of time here. Now, definitely write this down in your notes because this is a major type of question. It's not a difficult question, but it's a major type of question you'll be asked. Determine whether each of the following compounds would be best classified as ionic or molecular/covalent. Molecular and covalent are interchangeable. That's why you see both words there. A lot of times we like to use covalent, but I believe Cambridge prefers molecular, so either is fine. So remember, it's very, very basic here. Ionic compounds are going to be metals plus non-metals. Doesn't matter which one is in the front. It's always the metal first and the non-metal second. And then covalent, you're looking for non-metals only. You can really think of it, if there isn't a metal in the front, then it's not ionic. It's definitely a covalent compound. So let's take a look at each of these. NABR. Remember, every new capital letter is a new element. So Na and Br. Sodium, metal or non-metal? Metal. So if those are the only two types of compounds that exist, and there's a metal there, you know it's automatically then got to be ionic. And sodium's giving away an electron, bromine's gaining one. We know that information. I also know this is a solid with an ionic compound. All right, next one, NO2. A nitrogen and two oxygens. Everything here is a non-metal. So because everything here is a non-metal, that means this is. And so just, I'm going to write here underneath non-metal, non-metal, and here metal and non-metal. How we're making that decision. And this is a decision you need to make pretty quickly. All right, HCl. HCl. Is hydrogen a metal or a non-metal? Hydrogen is non-metal. So non-metal with a non-metal is covalent. And MgI2. Non-metal. So it's ionic. All right. So one of the things that you're going to be asked to do shortly is you're going to be asked to name mixed compounds, meaning you're going to have to name ionic compounds when they show up, you're going to have to name covalent compounds when they show up, and the naming strategies are different. You saw when we did class last week that the naming strategies for ionic compounds, we needed a Roman numeral when we had a transition metal, and then other than that, it was pretty straightforward. You named the cation, and then you named the anion, and dropped the ending, changed it to IDE. Last class, when you went through the tutorial, hopefully you saw that with covalent compounds, we did something a little bit different. You used numerical prefixes to actually say how many you have. Now, before I continue, why do you think that that would be true? Like, why do I not use prefixes for ionic compounds, but I do use them for covalent? I'll let you think about that. I'll answer in a little bit when we get to naming. But it's interesting to know that the naming strategy is different. So the next thing is the definition for molecule. Make sure you're writing it down. And then this is almost like a very repetitive term, but we're going to write it anyways because students do get confused with the differences between chemical formula and molecular formula. They all technically mean the same thing. So the first definition, and you've got to memorize this up here, is a molecule is a neutral group of atoms, so there's no charge, joined together by covalent bonds. You can only call covalent compounds molecules. Because inherent in the definition is that the atoms are joined together by sharing electrons, by covalent bonds, not by a transfer of electrons. So you're only allowed to call covalent compounds molecules. I've actually seen in a lot of middle school curriculums, or they've been made, where people will call salt a molecule, and it's not. You can't call salt a molecule because it's not sharing electrons, it's transferring electrons from sodium to chlorine. So be careful here. You can call water a molecule. You can call carbon dioxide a molecule. You can call sugar a molecule, but you cannot call any ionic compounds molecules. And then a molecular formula is just the chemical formula if we have a molecule. So CO2 is the molecular formula for carbon dioxide, is an example of one. All right, so I'm giving you about that 20-second heads up that I'm moving forward. So we're going to go ahead now to what I printed out for you, and what you already most likely wrote down the other day. When you're naming covalent compounds, you do almost the same thing for ionic compounds, except with one big difference. You have to use numerical frequencies for how many. And the reason why I had asked you is because in ionic compounds, you know how they're going to combine based on their charges. Like I know if Na is +1 and oxygen is -2, that there's only one way that sodium and oxygen can combine. Whereas with carbon and oxygen, there's a plethora of ways those elements can actually combine and share their electrons together. For example, carbon monoxide, CO, is one way. Carbon dioxide is another way, CO2. And they both work out, those compounds work out. And we're going to go over that another day, how to draw them properly. But because nonmetals can combine in different ratios to make stable compounds. Yes.
Pardon the interruption.
Yes. Yes? Hello?
Teacher's testing it.
Or she might just got her finger off the button.
Maybe. So you should have the reason why, because that might help you remember why you have to use this for covalent compounds than that ionic compound. So for ionic compounds, you don't use prefixes because there's only one way to combine a metal and a non-metal. It's based on the charge. Whereas with covalent compounds, because they're actually going to have multiple ways they could share electrons, and there's multiple compounds that can be made from the same two elements that have different ratios of those elements. So for example, carbon monoxide makes a stable compound with one carbon and one oxygen, whereas carbon dioxide makes a stable compound with one carbon and two oxygens. How would you know which one you have if you don't state it in the name? If you just said carbon oxide, nobody would know if you're talking about carbon monoxide or carbon dioxide. There would be no way to know. So that's why you have to use prefixes to say which one you have. Yeah. The passes up here. And so the actual naming strategy, hopefully you saw for covalent. I saw that many of you did that assignment pretty quickly last class. The naming strategy is actually pretty simple. The, I guess, semi-bad news is that you do have to, yes. Okay. Daniela? Yeah. Put it on your shirt. Jose Enrique? Janaya? And Miguel. Danielle, you fine? Okay. So, the semi-bad news here is that you do have to memorize the prefixes. A lot of them, though, you probably already know because they're the same as the geometric shapes from pens on. So, if I've got one of an element in a covalent compound, we say mono. Now, I'm going to put a star here, and I did advise you on Tuesday when I'd written that out in the assignment to make sure that you know only to use mono for the second element. If there's only one of the first element, you don't use it. So you only use for second element listed. But for everything else, 2 through 10, you use for both elements. So if I've got 2 of the first element or 2 of the second element, I use di. But mono, I only designate that word mono if I have one of the second element. And so using the example that is the most commonly known, CO is carbon monoxide. We don't say monocarbon monoxide, we say carbon monoxide. It's always implied that the first element you have one of, so you don't have to say it. And then if you have CO2, CO2 is carbon dioxide. I use these because they're commonly known, so it's easy to see. Carbon dioxide, I've got 1 carbon, 2 oxygens, but I don't use mono for the first carbon. Now, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, you do have to memorize those. But I think you've heard of diacetyl. If not, diacetyl. Tri, like triangle, 3. Tetra, 4. You may have heard of tetrahedral, tetrahedron, maybe not. That is a prefix for 4. Pentagon you've heard of. 5. And then hexagon, hexagon, octagon, nonagon, and decagon. It's the same as the geometric prefixes from 5 on. And so, yeah, you have to commit these to memory. And you are going to have a quiz on naming, very likely next week, in the last class period of next week. So give yourself a deadline to memorize this, along with the other thing I'm going to tell you to memorize by next week. And I was watching the videos before I posted them last class, and I saw that, I think it was the Professor Dave video I had given you all, and he was mentioning that, you know, there's actually not a ton of memorization in chemistry. There's actually not. But this is one of the areas that you have to memorize some information because it's how do we speak chemistry, basically. How do we speak about compounds? How do we communicate effectively? So there is a little bit of memorization here. But in general, there's not a ton of memorization in this class. It's more practice in solving problems. All right, so let's practice naming. I already did the other bit. But let's practice these in our notes. Name the following: PO3, N2O, and CO2. All right, so PO3. You have one phosphorus, but you don't use mono for the first element. So we would call this phosphorus. But for the second element, you do have to write this. You have 3 of them. And so this would be phosphorus tri-oxide. I'm underlining what I have to do. I have to write for the second element that there's 3 of them. And I always have to change the ending to IDE for the second element. All right, second one. 2 nitrogens. Do I have to designate that in the name? Always. If there's more than one, you always have to designate it. So di-nitrogen. Di tells me there's 2. And then I have 1 oxygen. So I have to say that. It's the second element, so yes, you do. So you would say di-nitrogen monoxide. And then this one is carbon. I already mentioned. All right, so that was covalent compound naming. Now, the other thing I wanted to bring up that I had given in the video was I told you to write down a bunch of polyatomic ions in that video, and that probably looks pretty scary. I am going to shorten the list today pretty significantly, but there's going to be some, bad news. And the bad news usually means that you have to memorize something. So along with memorizing the prefixes for covalent compounds, you are also going to have to memorize the polyatomic ions that I printed out for you. But beforehand, let's go over what they are. So polyatomic ions when Xavier comes back. Okay. So go ahead and write this down. Polyatomic ions, these are complex ions. They have more than one atom that share a charge. That charge could be positive or negative. So I have some examples here, but you may want to also write it like this. And write it large. Thank you. So what this communicates is one nitrogen atom and 4 hydrogen atoms. Yes. Yes. One nitrogen atom and 4 hydrogen atoms have lost one electron combined between them. That's what that states. And here, this says that one phosphorus atom and 4 oxygen atoms together have gained 3 electrons. That's what that states. So, a polyatomic ion, these are ions that naturally form in compounds. And they are composed of many atoms that are sharing a lost or gained charge. So they're complex ions. And if you think about it, even in the name polyatomic ion, poly stands for many. Many atoms with a charge. It's in the name. What's happening? These polyatomic ions, if you look closely, you're going to see them all over. If you look at your nutrition labels, you look at your shampoo bottles, if you look at your ingredients lists in containers, you'll find these polyatomic ions everywhere. I was taking Tamiflu because, as you all know, I have not been feeling well. And it actually says in the Tamiflu that there's phosphate. That's phosphate. So I've been taking this to help with symptoms of the flu. Polyatomic ions, if you read your ingredients list, they're in tons of materials. They're in a lot of the food you eat. Check it out when you get the chance. Read your ingredients labels. Read what you wash your hair with, your shampoo containers. You're going to see, after you go through these names, you're going to be like, oh, we use this stuff all the time. So here we go. Names of the most common polyatomic ions. Now, as you have seen, there was a pretty large list in that video, and that video didn't even have like, the largest list of polyatomic ions that I've seen. But I'm not going to have you memorize all of those polyatomic ions. I am, however, making you memorize all of these polyatomic ions. The reason why is because these are the ones that Cambridge uses. So these have to be straight up memorized. However you prefer to memorize information, you may want to consider doing flashcards. Some students do like Quizlet flashcards. You can make a Quizlet with them, but they need to be memorized. And what do I mean by memorized? You straight up need to know that whenever you see NH4 4 plus 1, that's called ammonium. It's called the ammonium ion. Whenever you see OH minus, that's hydroxide. Whenever you see NO3 minus, that's nitrate. SO4 2 minus, sulfate. CO3 2 minus, carbonate. Now notice, Taylor pretty much for the most part only focuses on the H ion. You'll have noticed that in the video, if you were writing down the other polyatomic ions, that there were also ite ions, there were hypoite ions, there were perrate ions. You don't have to know those, all the different variations for Cambridge, because they actually do things a different way, which we're not going to get into right now. But they only need you to memorize the main groups: nitrate, sulfate, carbonate. Now, it's a little bit complicated to do because you've actually got to memorize everything, meaning you've got to know nitrate is 1 nitrogen, 3 oxygens, and a -1 charge. NO3 minus 1 is nitrate. Like I said, I'm giving you about a week to do this, but you've got to memorize these. You will get practice in class several times with the Bellworth next class, and with, of course, the review day when we have it next week on Wednesday. Yes. I mean, we're in the middle of class. All right, so we've got 1 phosphorus, 4 oxygens, and 3 minus charge. That's phosphate. And so you'll see there's some that are interesting here that you may recognize. Have you ever heard of peroxide? Anybody ever heard of peroxide? Can you tell me where you've heard of it? Hydrogen peroxide. Hydrogen peroxide, believe it or not, is H2O2. H2O2 is hydrogen peroxide. Only 1 oxygen off from water, but completely different molecule, way more highly reactive, and it's because it's got that peroxide ion in it. Does anybody know what you use hydrogen peroxide for, or what you can use it for? Go ahead. It's in a black container, usually when you purchase it at like Walgreens. You use it to remove stains? Yeah, it's used as a bleaching agent, yes. It can be used for injuries. It will basically bubble the, like it'll. You're not supposed to use it, but you can. Yeah. People also use it to bleach their hair. And I think that's what you had said too, to get out of stains, right? So it's used as a bleaching agent. Sulfate, they add to a lot of shampoos. So look at your shampoo, especially if it's a cheaper shampoo, it'll use sulfate ions in there. However, if you have dyed hair, it actually strips the color out of dyed hair. So sulfate is an interesting one. Nitrate they use in cured meats. So nitrate is used in cured meats like hot dogs, and if you eat stuff like ham, bologna, that all has like nitrate in it. And so there's a lot of different places, like I said, where you'll see these polyatomic ions. So I do want to challenge you over the weekend to look over ingredient labels. Look at whatever containers, whatever materials you're using. If there's an ingredients list, look at it. And I bet you'll find a few of these. All right, so what do we have to do with polyatomic ions? The same thing we're going to have to do with all the other types of compounds. We're going to have to learn how to name with them and how to write chemical formulas with them. Because we're going to be able to need to see them on inspection. When we get to chemical reactions, we look at everything with chemical formulas. So it's really important that we do that. All right, check up. Write the chemical formula for each of the following compounds. have not memorized the polyatomic ions, and you don't have to yet, but you should start working on it. Go ahead and write the chemical formula. Yes. Damien had asked the first one. Damien. All right. So first of all, how would we know whether this is ionic compounds or covalent compounds? It's a good question, right? These are all ionic compounds. I'm going to make a point here of something that I just want you to know. Polyatomic ions would always be part of what type of compound? Yeah. There's a one. Somebody else asked. Polyatomic ions are part of ionic compounds. Always. Well, why would that be so? If it's implicit in the name polyatomic ion that that group of atoms has gained or lost electrons, that means that a gain or loss of electrons is taking place and it must be an ionic compound that you have. And so you may want to write that down. So if I want to get the chemical formula for an ionic compound, what do I got to do? This is what we did last week. Get the ion charge. So barium, what would the ion charge for barium be? So we'll start with Ba plus 2. Barium plus 2, group 2. We're good with that, right? You understand that? Okay. What about chlorate? How do I know this is a polyatomic ion? What's the little, somebody mentioned it, what's the little, woo, I got a polyatomic ion. What's changed? What's different? The ending is ATE. That's a communication. If you see that ATE ending, you definitely don't just have a single atom. You have a group of atoms instead. So with that ATE ending, that's a way to recognize for most of the polyatomic ions that you have one. Now, from there, you've got to memorize what is chlorate. At this moment, you haven't, most likely. So grab it from the chart. ClO3. And the charge is -1. -1. So if there's no number there, it's implied to be a 1. Now, here's my suggestion. Pay careful attention to this. This is a group of atoms that shares a -1 charge. You'll notice how I had written it before is I wrote parentheses around it. The reason why is because you cannot change what's inside of the parentheses. This polyatomic ion is fused together. So if I've got barium with a +2 charge and chlorate that has a -1 charge, how would I put together my correct compound formula then? Remember we used the crisscross method, so we swap, but this is where you have to be careful here. The 2 would come to the outside of the parentheses, and then the 1 would come here, and it would become barium. I don't have to write the 1, but kind of if you like, and then ClO3 in parentheses, and you put the 2 on the outside. Make sure to put the amount on the outside of the parentheses. So if there's more than one polyatomic ion, there's more than one of the polyatomic ion, you must use parentheses around the polyatomic ion and then put the number of how many you have outside of the parentheses. We're going to take a look at the next one. Ammonium nitrate. Ammonium. Wait a second. That's a polyatomic ion. How will you know that? Well, you're going to have to memorize them. Like, they got to be something that becomes like, oh, ammonium is that. Hydroxide is that. So ammonium is NH4 plus 1. So NH4 plus 1. And then what's nitrate?
NO.
3 minus 1. Those charges are cancel, but you can crisscross them if you want. If there's only going to be one of each polyatomic ion, you need to use parentheses. You're correct. You do not. You only use parentheses if there's more than one. So this would then become NH4, NO3. And this is the rare example of there not being a metal, but this is an ionic compound, because both of the groups of atoms here have charges, a cation and then anions. So remember at the beginning when I said ionic compounds are cations and anions, typically a metal and a nonmetal. It's not always a metal and a nonmetal because ammonium exists, but it's almost always. All right, sodium sulfate. Let's try this last one. Sodium, is that a polyatomic ion? No, that's an element. You find it on the periodic table. It's Na plus 1. And then sulfate, is that a polyatomic ion? Ends with ATE, so that's going to be a yes. So, there we go. SO4 minus 2. There's only going to end up being one of the sulfate, so you need to put parentheses around it. So you would do Na2SO4. Like that. So you put parentheses around a polyatomic ion if there's going to be more than one of it when you do the crisscross. Let me check how much further. All right, we just have a couple more slides. The next one we're going to do is mixed naming. So I'm not going to ask you to write this all down now. Next class, what I'm going to do at the beginning is, next class, what I'm going to do is I'm going to go over how to differentiate and ask you to write a chart out like this. Not exactly the same one, but very much like this in terms of how to differentiate your different naming strategies. But let's go ahead and go through some mixed naming beforehand. Name each of the following compounds. Go ahead and write them down. Because this is how it will be presented to you when you do take a quiz or a test, is you would just be given compounds to name. All right, next for the bathroom. Rachel? start naming compounds? Like, how do I know what to do?
It's a ion or
The first thing that I will check, is it ionic or covalent? So for A, which one is it? So that's the first question. Is it ionic or covalent? Why? Because, okay, so that's why it's ionic. Why should I ask that question? Perfect. So then, now that I know this is not covalent, I would not be saying di or tri. I know that that's not going to be my strategy. That's why I'm bringing it up like this. All right, the next thing you should check is it was ionic, right? So is there a transition metal? So is there a transition metal? And the other question you should ask is there a polyatomic, right? Is there a polyatomic? None of these have polyatomic ion because there's only 2 elements in total. One of the ways you could tell you have a polyatomic ion is there's 3 or more total elements. But this won't have a polyatomic ion. But is there a transition metal here?
Yes.
Transition. And so that's enough information to tell me what I need to do. What do I need to do then to name this right? Transition metal means what? Roman numeral. So this is going to be, because remember we use the reverse crisscross to figure out what the charge is. This is iron with a +3 charge. So that means this is iron, I, because it's iron with a +3 charge, and then sulfide. Iron 3 sulfide. BaCl2. You don't need that. Remember, nonmetals never get Roman numerals. Only the transition metal does. We know sulfur is -2 because of its position on the periodic table, so we don't need to say that. BaCl2. My first question, ionic or covalent? Which one? BaCl2. Ionic again, because barium is a metal. Transition metal or no?
No.
No transition. So this is the simplest strategy. Ba is barium. And then you just change the ending of chlorine to chlor.
I.
And then C. What about the last one? First question, ionic or covalent?
No, covalent.
Yeah, because the
Covalent.
beginning is not metal.
Yeah, they're both non.
Covalent.
You're just not gonna
Covalent. So because it's covalent, what does that mean I have to do? I know my strategy immediately once I know it's covalent. No, that's not even a question though. There's no metal, so there can't be a transition metal. We stop once we know it's covalent. There's nothing else to do. What's the strategy for covalent? We looked at it a few minutes ago.
Oh.
Use some prefixes to tell how many you have. So for F2O, how many fluorines are here?
2.
So we have to call it
Difluoride.
difluorine. And then monoxide. have one more step. Okay, ready? Last step. And then I'll have some practice questions for you. Maybe for the following compound. We're going to do the quizzes backwards today. We're going to do it at the end of class because I wanted to make sure to re-go over how to tell the difference between ionic and covalent. But this is going to be the last set we do before starting practice set. All right, so I'm going to tell you that I know immediately that there's a polyatomic ion in every single one of these. How do we know that again? I'm going to write it down. But what's the key here? What's my clue?
If it's not relational.
There's like when it's an ionic complex, like there's a capital letter.
Parentheses on one of them.
Oh.
Right. Yes.
Pardon the interruption.
Yes. Yes?
Can I borrow Jose Enrique for a few minutes?
Okay.
Thank you.
So ionic compounds with 3 or more capital letters, indicating that we have 3 or more elements. This tells you for sure, 100%, there's a polyatomic ion. What you should notice, most, not all, but most polyatomic ions have what element in them? Look back at the list. What element is in most polyatomic ions? Do you see it? Oxygen. It's in so many of them, most of them are actually just called oxyanions, actually. So you'll see that oxygen is actually in every single one of the polyatomic ions here. So what you're going to have to do is figure out, all right, so this is my metal, right? This is my polyatomic ion. You should underline it. Because remember, the polyatomic ion must be named as its own thing. And so let's go ahead and check it out. CaSO4. The first question, ionic or covalent? We know that every single one of these are going to be ionic because they have a polyatomic ion in them. So we know they're ionic. This is ionic. You still have to check, does it have a transition metal? Does it? Is calcium a transition metal? So if it did have a transition metal, you would have to put a Roman numeral, but you don't for this one. Welcome back. All right, Daniela, you're next. All right, so this is going to be calcium. And the end is going to be, what's that stand for? You can look at your chart. They will never show the chart because the chart always cancels in the final compound. So which one's SO4? Calcium. Na2CO3, second one. Na is the metal, and then this other part would then be non-metal polyatomic ion. It's ionic again. There's no transition metal. So sodium, we just named sodium. Yes. And then CO3 you have to find, and it's carbon. Sodium carbon. And then finally BaOH2. Barium. OH2. It's I. Drop. All right, so in this case, it's easy to find the polyatomic ion inside the parentheses. So if you see inside the parentheses, you've got something, that's definitely going to be a polyatomic ion. And then you just consult your list for now, and you're like, okay, that's hydroxide. That list does, like I said, it has to be memorized, but it has to be memorized by next week, Wednesday, so you've got some time. Go ahead and sign in for quizzes now. Like I said, it's going to be backwards today. I have a quizzes at the end of class. It's not going to include polyatomic ions, but it is going to include mixed covalent and ionic compound naming because you do need to get some practice on it. Go ahead and get signed in for it now. You've got about 3 minutes before I get started with it. But that's the end of the lesson for the day. And then next class, you'll get practice with polyatomic ions. Your homework for the weekend is to start writing out flashcards for your polyatomic ions so that you memorize those. Work on memorizing your polyatomic ions. All right, so once again, you're signing into quizzes now. You've got 2 minutes till I press start. You'll get some opportunity for game points. And this goes into participation. All right, 1 more minute to get signed in for quizzes. I'm pressing start now for those that are ready.